Hello and welcome to Unit 2. We're going to talk about vectors, and you've probably already talked about that in math and in science before. Why are vectors so exciting? Why do we really care? Well, if you look at this picture, I put that on there to sort of grab your attention. See this great big Tyrannosaurus Rex, I believe that's what he is. If he were chasing these guys at a particular velocity, and he were going this exact direction, let's say this is due north, what if we turn his direction just a little bit? And let's say he's traveling, maybe 10 degrees to the east of north. Well, would these guys have to be so afraid? No, they wouldn't, because he'd be going a very different direction. So remember, vectors are really important because we're going to talk not just about the magnitude of his velocity, but the direction of his velocity. That's really critical. So the difference between scalars and vectors. Scalar is something that does not consider the direction. So speed is a scalar quantity because it is only, say, 45 miles per hour. Is all we're talking about. We are not talking about the direction it's going, simply the magnitude. When we talk about a vector, velocity is a vector because not only are we concerned about the magnitude, like 45 miles per hour, we're also concerned about the direction. So a vector constitutes both magnitude and direction. Here are some examples of scalar quantities and vector quantities. So once again, it's just a scalar has only magnitude, a vector has both magnitude and direction. So examples of scalar quantities would be the speed, length, area, volume. We don't care about the direction on any of those, we just care about the magnitude. Mass, density, pressure, temperature, energy, entropy, work, power, those all are scalar quantities. They do not have a direction involved. Vector quantities, here are examples of those. Velocity, we've talked about that. Acceleration, we've talked about that. Those are vectors. Displacement as well, because it has direction to it. Other items or other things that we'll discuss later on in physics, momentum and force, those will all be vector quantities as well. So here are just some pictures showing velocity vectors. The velocity that this is traveling in his arm and the direction that it's traveling. One thing to remember from when you've studied vectors before, the length of the arrow represents the magnitude of the vector. So here, if we have a vector, we draw our vector in a particular direction. The direction is important, and the length of the vector itself, of that arrow, represents the magnitude of that. So if we're thinking that this is representing velocity, it would be velocity in this direction, and the length would represent whatever that velocity is, so many meters per second. Here's just another example. We have the propeller taking the plane at a particular velocity this direction. We have wind that is countering that at that direction. And this would be a smaller magnitude than this vector. So the length of the arrow represents the magnitude of the vector. Another convention that will be used in your textbook and throughout our course in physics is that when we write down equations and we are representing vectors versus scalar quantity, if the variable is written in bold type, it will be a vector. So this is representing the vector velocity of 3.0 meters per second. And something is traveling at that speed. Scalar, however, will be represented in italics. So if this is represented, I am only talking about speed here, 3.0 meters per second, and I am not including a direction in that. This would be representing a scalar quantity. This is just a picture showing some more vectors. The displacement vector here, the velocity vector, the acceleration due to gravity vector. Those are all representing both magnitude and direction. Now, what happens if we want to add vectors together? Let's say that we have an object and it travels at this velocity and in this direction, and then it changes direction and velocity and goes in this direction and velocity. So we have vector A and we have vector B. A couple more conventions. When we write vectors, we can write them with a little arrow over the top. That indicates that it's also a vector. If we have vector A plus vector B, how do we find the sum of that? Well, the sum we're going to say is vector R, and we can add them together graphically. How do we do that? Well, we take vector A and we take our protractor. Let's say you're given some degrees above horizontal, that this is the direction this vector is in, and you are told that it is, so many centimeters. Well, you would need to draw that out. If you're given it in kilometers, you will have to make a scale in order for that to fit on your graph, and you will simply draw that graphically. Then you will look at the information for vector B. You will draw it graphically on your scale. Then you will take your ruler, dot, 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 dot. You'll connect the lines from your starting point to your ending point, and that is vector R. And you can take your protractor, you can measure how many degrees this is from horizontal. You can measure the line itself, and you can determine the sum of vector A plus vector B graphically. So once again, if we have vector B and a vector A, we can add them together graphically by simply plotting them down on graphing paper, taking our arrow of the resultant, which is vector C, and just arbitrarily calling it vector C in this case, and that is the sum of vector A and vector B. Vectors can be added in any order. So as far as order of operations goes, you can see that if we take vector B plus vector A, the resultant is vector C. Or we could take vector A first and then vector B. The resultant is still vector C. We can add more than two vectors together in any order, so we can add here 3 different vectors being added. It does not matter the order of those. The property is the same, or is that we can add them in any order. Here we have 4 different vectors being added. That resultant will be the same. And go ahead and try it. Pick 4 different vectors and add them in different orders and see what you get. You should get the same resultant. So how do we subtract a vector? Actually, it shouldn't say subtracting 2 vectors. It should say subtracting 1 vector from another. So that's not a very good way of wording that, I don't think. But so let's look at how we subtract 1 vector from another. Let's say we have our vector A, and we want to subtract vector B. How do we do that? We just add its opposite. That's what we do. So you see vector A is right here. You can graph that, vector A. Then look at vector B. I'm going to subtract vector B. So I am going to basically add its opposite. And you'll see vector B here. When I graph it, I will graph it in the opposite direction like that. I'm in essence subtracting it. I'm adding its opposite. Then the resultant will be vector C. And that's how you would subtract a vector. What happens if I'd like to multiply or divide vectors by scalars? Now, for the scope of what we are going to do, we are not going to be multiplying or dividing vectors by other vectors. If you would like some advanced, a little advanced work, look into what the rules are for that. They're special rules, and we're not going to do that Overall, that will not be required. But we do need to know how we multiply or divide vectors by scalars. Okay, and here is the rule right down here. If I take a vector times a scalar, I always get a vector. Or if I have a vector divided by a scalar, I always get a vector. The same is reverse. If I have a scalar times a vector, I get a vector. If I have a scalar divided by a vector, I get a vector. So an example of that, let's say you're driving in your car and you're going 40 kilometers per hour north. That's a vector. You have your velocity, your magnitude of your velocity and the direction. And you are doing this because there's road construction. You have to go kind of slow. 40 kilometers per hour is roughly 25 miles per hour. Well, let's say you see your end construction sign and suddenly you are able to go back at the speed limit. You multiply your velocity by 2 because now the speed limit's about 50. So you get to, or 80 kilometers per hour. When I multiply this scalar, this 2 quantity, times the vector quantity, I will get a vector. I will get 80 kilometers per hour for my magnitude, and north is my direction. So when we have a scalar and we multiply it by a vector, we always get a vector. Advanced idea. Go ahead and see what happens when you multiply 2 vectors together. Some interesting rules there, and I look forward to seeing you in class.